right. Well, good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. Happy World Ocean Week, everybody. We have an amazing series of live events all week long in partnership with the Explorers Club. We are going to explore the deep sea, exciting marine life, the green ocean, and of course, we're going to spend a lot of time checking out sharks. Friday is our big shark day. So I'm going to share a link here down at the bottom, exploringbytheseat.com/Ocean Week. You can find all the events that we have coming up this week, how to register, to tune in live via YouTube, to tune in afterwards on YouTube, or maybe even snag a camera spot if something's open in one of the events. So today is a pretty special day. Monday is our deep sea day. So we've already talked to Richard Garriott, president of the Explorers Club, who just recently went down in a submersible to Challenger Deep, the deepest point in our ocean. We just got off with Pete Gerges and Andrea Martinez, who showed us some amazing deep sea creatures in their lab at Harvard University. And we're going to wrap up our deep sea events with a virtual field trip to the Pacific to spend a little time with the crew of the exploration vessel Nautilus. So we're going to join the team as they're exploring and mapping the sea floor around Johnston Atoll in the Pacific. The Ocean Exploration Trust and the Nautilus Exploration Program aim to explore the ocean, seeking out new discoveries in the field of geology, biology, maritime history, archaeology, and chemistry, while pushing the boundaries of education, outreach, and technological innovation. So we have Abraham joining us, a science communication fellow, as well as Jashida, who's another science communication fellow on board the Nautilus right now. And we're going to have a special treat and jump to the back of the ship and meet Lindsay G soon. But for now, let me bring in our SciComm fellows. How we doing, everyone? How we doing, crew?
Hello. Doing pretty good.
Doing great today.
Awesome.
Thank you for having us.
Yeah, it's
So
so
I'm
great to have
Abraham
you.
Currington. Oh, yeah, go ahead.
I was just going to say, it's so great to have you joining us live. We've got classrooms all across North America hanging out today. It's going to be a lot of fun.
Nice to meet you guys. I'm Abraham Currington. I am a science communication fellow. I'm also a professional illustrator and cartographer, so I make maps and comics when I'm on land.
Yeah, and hi everyone. My name is Dashida Cruz Rodriguez. I am also a science communication fellow here on board. And when I'm not here, I'm a graduate student of instructional design and technology at UCF. And I'm also an environmental and marine science educator for non-formal environments.
So we are both part of the Corps of Exploration. Pop this up. So our goal is to, when we're science communication fellows anyway, is to learn about what's going on and the science that's going on the ship, and then communicate it back to you at home. So we're kind of your link to our operations here, and we hope to be good role models and mentors for up-and-coming scientists and engineers. So that's what we strive for. Let me show you what the ship looks like. This is Nautilus. So we are right up top in this white box here. That's our control van. So if we had robots in the water, our remote operated vehicles, the pilots of those robots would also be up here with us. And this white globe on the back, that's our connection to the internet. So that's how we're talking to you right now. And then later on, if you see this yellow crane right here, that's where Lindsay and his team will be. So they'll be talking to you in just a little bit. So right now we're bobbing around in the Pacific. I can show you a little map of where we are and where we've been. So this is the area that we explored earlier in the season, Kingman Reef and Palmyra Atoll. We're mapping around Johnston Atoll. We're more like in this area right now, but we are hanging out near the Hawaiian Islands. We're about 3 days out from Honolulu, which is where we set sail from a few weeks ago. And then, speaking of our robots, up front here is remote operated vehicle Hercules. So it's got this yellow up top, which helps it to float, even though it's several thousand pounds heavy. I don't know how heavy it is, but it's pretty heavy. It's about the size of a small van or car or a large car. And it has cameras on the front and manipulator arms so it can grab samples from the seafloor. And then the back here is Argus, and it works with Hercules to do our remote operated vehicle dives. And I can show you how all of that works out. So up top, we have the ship, which is where we are. We don't go in the robots ourselves. We control them from up top on the ship. They are connected to the ship through a fiber optic cable. So Hercules will be down at the bottom, getting videos, collecting samples. That information gets transferred up via a cable to Argus. And then Argus transfers that information up to the ship. And then that white globe we talked about, that communicates to a satellite in the sky that our data, and the data is beamed down to a satellite substation and then goes for quick processing and out to you. And that takes less than a second. So just a blink of an eye. And so that's how we're able to keep our connection with you. And I did mention that we were hanging out in the middle of the ocean, but what we're doing right now is mapping. So, Jashira, did you want to talk about our mapping operations?
Yeah, of course. So, what we do in order to map the seafloor is that we use a multi-beam sonar. And that piece of equipment actually allows us to use sound to bring pulses of sound down to the seafloor. And the time it takes for that sound, and you'll see it right now on the screen, the time it takes for the sound coming from a multi-beam sonar to travel all the way down to the seafloor and then return back to the ship goes into a computer and allows us to create these beautiful and colorful, very detailed maps of what's down there. So as you can see right here, it looks like a really thin line, right? So that means that we're constantly going back and forth to slowly reveal the shapes of the seafloor. And when you see cooler colors on those maps, that means that those areas are very, very deep. But if you see brighter colors, such as these, that means that we're getting a little bit shallower in the water column. Now, all of this is really important for us to do because very little of the seafloor is mapped. So, if you guys have ever gone on Google Earth or Google Maps, the satellite version, you might notice that there are different folds and shapes on the seafloor part. And that is actually mapped with a satellite. So the satellite can't really go below the surface of the water. So that's why we need to use the multi-beam sonar to actually really reveal what's actually down there. Now, Adrian is about to show you an example of the type of product that we are producing here in Johnston Atoll. So generally, we have a blue outline of the seafloor that's not very detailed. And then we reveal very colorful maps of what's down there. So the darker blues are actually the initial map, and then the colorful parts are the very detailed maps that we come up with. And the reason we do that is because it informs the science that happens afterwards. So we create some baseline information, and then we collaborate with the scientific community at large for them to actually come back to these places and study them at depth. Now, one step that comes before that is that we actually bring our ROVs down to the seafloor. So these maps can actually inform our ROV dives in the future. Now, the reason we're here in Johnston Atoll is because we're mapping the exclusive economic zone. Now, the exclusive economic zone is a special area that goes from the coast of a place out into more or less 200 nautical miles. It can vary depending on the country, but in the United States case, it's 200 nautical miles out into the sea. And that area is actually managed by the government of the United States. So if you look at this map, you'll see some yellow outlines, and those yellow outlines highlight the exclusive economic zone. The red parts are all of the unmapped areas. So as you can see, we have a really large undertaking in our hands. And there is a project known as Seabed 2030 that is aiming to combine data coming from all over the world to allow us to create maps of the seafloor at large. But the United States also has priorities. So we are currently mapping within the areas of priority for NOAA. Now, soon you're gonna see our mapping team go out on the aft deck to deploy a piece of equipment. And that piece of equipment is known as a UCTD. I know Lindsay will jump in and tell us a little bit more about it, but we need to deploy these extra pieces of equipment into the water column because they're going to inform the data that goes out into our sonar.
Oh, and there they are. So let's pop over to the crew on the back deck. Hey, Lindsay, can you hear us back there?
Yeah, I've got you back. Got you back here. Do you hear me okay?
Yep.
Oh, great. Yeah. Hey, hi to everybody. And I'm Lindsay, and I'm the mapping coordinator on board. And we've got Ariana, who's from Florida A&M University, is one of our mapping interns, and Elijah, who's from Tuskegee University out here. So I'll get Ariana just to bring out the. So one of the problems when you're mapping the seafloor, it's not like mapping land or even a planet. You never see it. So we have to use acoustics. And one of the reasons that's a problem, because putting sound through the water, you never know, it's not a straight line. So we need to know what the sound velocity is in the water column, so the rays of sound. So we have to measure and correct those. Couple of ways we do that, and the main thing that it affects is the temperature affects that sound velocity. So this is a probe we're going to drop in a minute. And so this is a conductivity, temperature, and depth probe. So we have the depth and the temperature, and the conductivity, we can also work out what the salinity is of the seawater. So that also affects the way the acoustic rays go. So what we do is this goes down. You won't see the whole thing unless you're here for 20 minutes, but we drop the probe, and then it goes down to about 500-600 meters when we drop it. Then we recover it, and we take it inside the wet lab, and we download the data that it recovers. So that's how we then apply that onto our sonar to make sure it's accurate enough, and the acoustic rays, we correct them for the way they bend. So we're going to check now that we're ready to drop. If you can, Elijah, check with the data lab to make sure they're ready. Ariana, if you can come around. Okay, when you're ready. And 5 seconds, put it down, stand by. Okay, when you're ready. Okay, so we drop it here, and then we're going to wait 5 minutes now, so that'll be about 500 meters when it goes down. And then we'll recover it later on. Okay, that's it from here for now.
Thank you, Lindsay.
Awesome, thank you.
All right, and I think this might be a really good time for us to show everyone our progress over on Johnston Atoll with our mapping operation. So we have actually a really exciting map. It's under mapping overview of the progress we've accomplished so far in Johnston Atoll.
Is that this one?
Yeah.
Okay.
There you go. So you can actually see our.
There we go.
There we go. You can actually see that circle over there that actually demarcates the EEZ, the exclusive economic zone, and then you'll see a bunch of little stars around that area. So those stars are going to establish our expected dive sites for our ROV expedition that's upcoming next month. So as you can see, we have a colorful line going all the way from the outside of the exclusive economic zone to the inside of Johnston Atoll. And all of those colorful areas are the areas that we've mapped so far. So you're going to see that they're going to start overlapping those stars. And sometimes we might prioritize areas that look a little bit more interesting. So that way our next expedition has better data and they can come in with the ROVs.
So that Goodness gracious. There we go. So that's what we've been up to out here on our mapping cruise. You want to open it up for questions?
Yeah, of course.
All right, excellent. Well, thank you so much for that great little lesson, little look at what you've been up to with the mapping, for the crew out on the back and doing that for us live. That was really, really cool. I know we're going back in time to talk to you right now. It's early in the morning, so we really appreciate you being up and spending a little time with our classrooms across North America today. So a quick question before we start the Kahoot quiz, and then we'll do some Q&A action. The sea floor, how much would you estimate that we've managed to map so far?
Yeah, they're working on a fresh number because it's constantly being updated, but it's a little over 20% is what we've mapped of the seafloor. And since the seas are about 70% of Earth, that's not a whole bunch, so we're working on it.
We still have a ways to go, definitely. All right. Well, I'm going to share my screen here. The Kahoot's just loading in the background. There is a link that is very important to our classrooms. It's kahoot.it. If you follow that link, it's going to ask you for a PIN number. I'm going to share my screen, and I'm going to put that PIN number front and center on the screen for you. So here we go. Let's get that share going. All right. So kahoot.it, and then the PIN today is 9496628. So we'll give a minute or so to let some classrooms come in and join us before we go live. A few things to think about with our Kahoot. There are some multiple choice. There are some true and false. You have 20 seconds for each question. You get the answer right, you're getting some points. The quicker you get the answer, and if it's right, you get even more points. If you're really fast but put the wrong answer in, you got nothing. We got to get that answer correct, and then you have to get it in as quickly as you can. So lots of students, lots of classrooms joining us. If you have one-to-one technology, then you can join right at your desk. If not, no big deal. Your teacher could put it up on the board, the smart board or the projector, and you could yell out your answers that way. So a few more seconds to get a few more students in here, a few more classrooms, and then we'll take things live. Because we all know we want to see that podium, that coveted 1, 2, 3 spot. All right, maybe 10 more seconds. People are still joining, but we want to get it going so we can get our Q&A going. All right, here we go. 20 seconds. First one is a multiple choice about how much of the sea floor has been mapped. Was it about 10%, about 20%, about 50%, or about 75%? You've got about 10 seconds left to get that answer in there. Last 5 seconds. All right, good job, crew. Couldn't fool these students. About 20%. Let's see what that does to our board. The cheerful finch is holding down that top spot, but it's pretty close. Let's go to our next question. See how we change. A little true and false action. Brighter colors on the seafloor map mean it's very deep. Is that true or false? The brighter colors mean that it's really deep. Got 5 more seconds on the clock there. All right, good job, crew. That is absolutely false. Those darker, colder colors signify the deeper water. Our leaderboard, the Honest Fox, has jumped into first spot. Let's go to another multiple choice and see what happens. The exclusive economic zone stretches how far from the coast, blank from the coast? Is it 10 miles, 30 miles, 100 miles, or 200 miles? So around the country, how far does that zone stretch from the coast? A couple more seconds. Ooh, a little split, but 200 miles. A few more students went with the 200 miles. So let's see what that did to our leaderboard. I think we're going to have a little bit of movement. So the Honest Fox is holding down first place, but the Prairie Tiger has a streak, an answer streak of 3 going. Let's see what happens with our last true and false. We use acoustics to map the seafloor. Not the best picture here. This is a hydrophone, so listening for sounds, but the best I could do with the quiz program on the fly. So we use acoustics to map the seafloor. All right, good job, crew. We can get lots of really cool information using acoustics about the seafloor. Let's take a look at our final podium before we jump to a little Q&A action. The Blue Impala in third. The Honest Fox in second. And ooh, the Rocky Echidna sweeping in at the end to take that top spot on the podium. Let's bring that share screen back, shut down our Kahoot, and let's switch gears. Let's go to a little Q&A action. Good job, everybody. Shout out to the Rocky Echidna. Okay, let's do a little Q&A action. If you're tuning in via YouTube, use that chat sidebar to get a few questions in here. In fact, let's take one from YouTube to start. Mr. Walsh's crew is tuning in with us, and they're wondering how long is the average expedition, and how long will you be at sea this time around?
Yeah, so our average expedition where we're out in the Central Pacific Ocean, it's about 2 to 3 weeks on average. I would say more toward the 3-week mark, especially because it does take us a few days to get to our dive sites and our mapping sites in the first place. So as Adrian said earlier, it took us about 2 to 3 days to get out here to the EEZ within Johnston Atoll, and it's going to take us 3 days back of mapping and transiting.
Yep. They have a max of 40 days, so the ship can only be out for 40 days, and then it needs to go refuel and restock food.
Yeah, and just to be specific, this expedition takes 24 days total.
All right, great question to get us started. Keep the questions coming via YouTube, but let's bring some smiling faces in with us, because that's always fun to see some classes. So, where should we go first? Miss Dillon's crew in Farmington, Missouri, some grade 7 and 8s with us today. Let's bring them in there. Hey, Missouri, how are we doing today?
Great. Are there any creatures or landforms that you all have discovered that have never been seen before?
Okay, so they're wondering, has Nautilus ever discovered any interesting creatures or landforms?
Yeah, absolutely. We discover. We don't discover, but we're exploring. So we have run across some very interesting creatures. We found an acorn worm hanging out on the seafloor recently. Actually, yeah, let's pop over to. We have a video. This is a hagfish. Hagfish are interesting creatures. They're covered in slime. They produce just buckets and buckets of slime. We found out on my last cruise that they are edible. If you ever wanted to try some hagfish, it's something that you can do. But yeah, we run across interesting creatures all the time. As far as if something is new or not, it's hard to say in the moment. Our marine biologists can say this looks new, but then we have to take samples. They have to run tests, and usually it takes over a year or more to find out if that thing that we saw was actually new or not. So it's hard to say if we see new things, but we see interesting things all the time.
All right, awesome. Let's visit another one of our live classrooms here. Let's go now to Sterling, Virginia, some 4th graders hanging out with Miss Carnes. Let me bring them into the call. There. Hey, 4th graders, how we doing?
Yeah. Hi, it's us. Say over. Hi, guys. All right, Ryan, come and ask your question. All right, we have a question. He's going to come on up.
So, have you ever found a sunken ship, like maybe a Navy ship?
Yeah, we have definitely explored areas of the seafloor where there are one or more ships. There was actually a time in Nautilus's history where we were focusing on an area of the ocean that had a whole lot of sunken ships, and we treat them as museums, underwater museums. So whenever that happens, we'll go to the side, we'll take video and explore it for the benefit of the scientific community, but we will leave everything respectfully down on the seafloor. Good question.
All right, let's grab another one from our YouTube crew here. So Miss Price's class is joining us, and Victoria wants to know, do fish or any other marine life affect the return from the sonar beam in any way?
Yes. Yeah. So so we use multi-beam sonar. We also have single beam, but the advantage of multi-beam is it's about 450 different rays that come out. So if something does bounce off a fish or a bubble or really anything that's in the water column, um, we might get like a micro hole in the data there, but it's got all the other arrays around it, so we can figure out what it should have looked like there. But yes, unfortunately, it's not so clear as we just see like a whale-shaped hole. That would be really cool, but yes, any kind of bubble or fish swim bladder or anything like that will interfere with it. But there's so many rays that it's okay.
Yeah, and something to point out is that we have a team of mappers who are actively in our data lab looking at that data as it comes in, and they go through a process where they clean it up and make sure that it's accurate as possible.
All right, awesome question. Keep those YouTube questions coming. I see a few more there. We're going to come back there soon. A few more camera classrooms. Miss Lascombe's group is hanging out with us. They're in Virginia as well. Let me bring them front and center. I see them waiting for us. Hey, fourth graders, how you doing?
Hello.
There you are.
Have you guys searched the Mariana Trench? And if you have, how deep it is? How deep is it?
Have we? I want to say that we haven't. I'm not positive. I don't think that we have, but it's about 10,000 meters deep.
36,000.
Is it 36,000 meters?
No, feet.
Oh, feet. Sorry. I was like, what? Am I that wrong? 10,000 meters deep, 36,000 feet. Yes. And so if you want to think about it, most of the seafloor is about 4,000 meters deep. So it's about double the average of the seafloor deep. So it's really deep.
All right, great question. So that brings a question from the chat up front and center. Someone was wondering, what's kind of the average depth that Hercules and Argus are exploring at?
Yeah, of course. So they have a maximum of 13,000 feet. So that's 4,000 meters for Herc. Argus is kind of restrained to Hercules' maximum depth, although it can go up to 6,000 meters. Generally, they're not going all the way down to their maximum depth. I would think the maximum, I think I read recently that during our Palmyra Atoll expedition, we actually reached a record in terms of the maximum depth that we were able to dive, and it was a little bit over 3,000 meters.
I believe when they do the mapping, they draw a red line about 3,900. So they're like, we've got a 100-meter wiggle room just in case.
Right, let's bring in another camera crew here. Here we go. We're going to go to Canada this time, in Ontario. Miss Riddle's crew is hanging out with us, so let me bring them in front and center here.
Awesome.
Madam Riddle's crew, if you're there, if you can unmute for us, we'd love to say hi and grab a question.
Oh, we had a question from my class. Someone was wondering, how long has the ship been collecting data?
Yeah, didn't we acquire it in 2009, I believe?
We acquired in 2008, and then we started going out on exploration expeditions in 2009. Yeah.
And so this is trip number 140. So give you an idea.
All right, let's dip back into our YouTube pool of questions. Cole is joining us. Cole's in grade 5, and Cole wants to know the sonar. Do you think it has any impact on the marine life? So we talked about how they can impact the data a little bit. Do you think the sonar has much of an impact?
So far, we have not observed any impact. I can say that when we put remote operated vehicles, the robots in the water, they don't necessarily damage the sea life, but they are loud, and they're bright. So the sea life will tend to stay away. So that's usually what happens, especially like we're a ship and we're making noise. So sea life will tend to kind of stay away from us. So they kind of see us coming and they kind of say, yeah, I'm not gonna go around that noisy ship. So. But so far, we haven't. Scientists haven't observed any damage from a multi-beam sonar.
Yeah, in our sonar, it's out of the range of hearing for many organisms.
Okay. Let's go to another question here. Mrs. Marquardt's class is joining us. We've got a great crew from Sterling, Virginia joining us today. Let me bring them in front and center. There they are. All right, fourth graders, we're ready.
Okay. What is your favorite part about your job?
Oh, that's a really good question. Well, for me, my favorite part about the job is twofold. So one thing is that we get to reveal things that no one has ever seen before. So this is a really unique opportunity. And the second part is that we actually get to share it live with you guys in your classrooms and at home through nautiluslife.org. How about you, Adrian?
Yeah, I love that I get to learn all different types of things. So I don't just learn about mapping, but I can go up to the bridge and learn about navigation. I can take a tour of the kitchen. I can go to the engine room and like see how that works. And then of course I get to communicate all of that to you guys. So it's really fun being able to explore just on the ship and in the ocean.
All right. Well, our camera classrooms, if you do have a follow-up, if you want to just send me a message in the chat, and that'll be my message. I know we have to visit your class one more time because we still have a few more minutes for a little Q&A action. So let's grab another question here to get us started. Mr. Strange's class, some grade 4 is a virtual class. Bree and Jackson are wondering, can you tell us about maybe some more of the sea creatures you might expect to encounter in this area if you were using the ROVs?
Yeah, I think we actually have a highlight video right here of a 6-gill shark that we encountered a few years ago. And our upcoming cruise is going to be deploying the ROV. So we're going to be seeing a lot more of that exciting footage very, very soon by the end of this month. But here's just a little taste of what we encountered close to the Pacific Remote Island Marine National Monument. So it wasn't exactly around Johnston Atoll, but very close in this region. And sometimes we see really impressive, charismatic organisms such as this shark. But sometimes we are looking at a whole lot of invertebrates who are interesting in their own right as well. So hours might pass by and we might be looking at coral, sponges. Those are really important organisms for our scientists because they require very specific conditions to be able to grow at these depths. So generally there needs to be the right currents that can bring all the nutrients up because corals and sponges can't move, so they need the food to kind of come to them, and just like that we might be looking at other invertebrates like sea stars, sea cucumbers, acorn worms. So I definitely encourage everyone to follow along our next expedition on nautiluslife.org.
All right. Well, our group in Farmington, Missouri have a neat question they did put in the private chat about science and art. So I'm going to bring them in and see if they want to ask that one live.
Oh, yeah. So Abraham said that she was both an illustrator and a scientist. So we were wondering how you came about to be in the place that you're in as a scientist who's both artistic in nature and then also science minded.
Yeah. Absolutely. I would clarify, I'm actually not technically a scientist. I did not study science at all formally. I took science classes, but I don't have a science degree. There are artists, scientists who double major in college. So that is a perfectly acceptable pathway. But I studied art. So I got a bachelor in art in college. And I always enjoyed making maps. So I'd make illustrated maps. Kind of, like fantasy maps for books, and I would illustrate books and I would make comics just as an artist. But I was very nerdy. I would calculate physics equations for fun. I would go stargazing. I loved looking at rocks. So I just liked that, as a hobby. And then I decided to get a graduate certificate in cartography. So I just knew a little bit more of the formal principles, and knew about GIS cartography, which is slightly different. So yeah, it's just following curiosity, and you just see what programs will accept artists that aren't scientists, or do both.
All right, very cool. And I think that's a really important thing to think about is, science may not be the career path for everybody, but that doesn't mean that you can't still interact. Like aboard Nautilus, there's not just scientists. There's, from the cook to the ROV pilots to the navigators, there's engineers. I mean, there's so many different careers, and you can still have a role in ocean exploration.
That's definitely true and very important.
All right.
Our chef is very important.
Absolutely. So Nautilus, another class is wondering, the ocean is not always a cooperative place. Has any gear ever been lost to the ocean?
Yes. Well, not lost to the ocean, but I'll tell the ROV story. So recently, one of our cables malfunctioned. And so I showed that Hercules is connected to Argus. Argus is connected to the ship. The link between Argus and the ship failed, and they both disconnected from the ship. So what happens? I mentioned that Hercules will float. So untethered Hercules, it floated up to the surface. We grabbed it. And Argus just sinks like a stone. It's just like a weight to the bottom of the seafloor. So we had to call on our friends in the area. They brought out their ROV and were able to attach a new cable to Argus and pull it up. So it happens.
All right, I do remember that, and I remember part of that mission, I think, was broadcast live too. So I'm sure there's a lot of people holding their breath while that was happening on the seafloor.
Yep.
All right, camera classrooms, we're almost out of time, but give me a wave if you want me to come back to your classroom. If you have another question in your classroom, we'll come back. All right, I do see some waving, so let's start with Mrs. M's crew.
Go.
What's the longest amount of time you've been on a ship?
Yeah, for me personally, it would be a little bit over 3 weeks. So very similar to what we're doing this time around.
Same for me. I was going to be on a ship for 2 months. So that's in the middle of the ocean for 2 months. And I decided not to do that one. But yeah, you can be at sea for a pretty long time sometimes.
Yeah, so for example, Joe was mentioning we have a really important crew who is like the life and blood of this vessel. They keep us fed, they keep the ship going, they make sure everything's working appropriately. And a lot of our crew will stay out here for 4 months at a time before they get to go back home.
No, they do get to touch shore in the middle though. So just to clarify.
All right, Mrs. K's fourth graders, I'm going to bring you in for a question.
Hi there again.
What is your favorite part about being on the Nautilus?
Yeah, so like we said before, it's about the learning and following curiosity and just being able to discover new things every day, whether it's about the ocean, the ship, the operations, or our fascinating shipmates.
Yeah, like a little bit more about ship life. We're not just sitting here communicating with you all day. We do get to take a break. I played some Mario Kart yesterday with my shipmates. So we do get to eat, we get to sleep, and have a little bit of recreational time too. So it's just, you're living life aboard, and then you also have a job that you have to do.
All right, good question. I'm going to just check in. Oh, no, never mind. We'll check in with Miss Lascombe's crew and see if they have a question. Yep, there we go. I see a wave. Oh, can you grab the mute for me?
How long does it take you to like build the robots that go underwater?
Yeah, so it's a team of engineers that design and build those, and it takes about 2 years. So it's quite an operation, and I think that's 2 years from like design to actually being built. But also, I was doing some work. I was having to illustrate HROV Nui, and it keeps changing. Like they'll put it in the water, and they'll think, it could also have this feature, and then they will like go and change it. So just because it's built doesn't mean that it won't get altered afterward. They keep tinkering around.
All right. And one final question here from YouTube. Miss Milson's crew is tuning in, and they're wondering the technology, like the ROVs, are those really challenging to use? Or is it kind of is, what's it like to pilot? Is it challenging?
Yeah, I would dare to say it's one of the most challenging aspects of the job here on our operations. So our pilots need to be really aware of what the priorities are for our scientists, about what the bridge is doing and how they're moving the ship. And they also have to be aware of what the robots are doing down there. And it's almost like a dance, right? So the cable can easily get intertwined, and that can be a really big hazard for them. So they need to be constantly collaborating and focusing on the operation. So yes, indeed, it is very challenging, but it is possible if you really put yourself out there and in that experience, such as our internships. So if you guys are ever interested, we do have an internship program that you can join as an undergraduate student.
And I just popped up on the screen. This is the row that our pilots sit in. So if you see the light gray kind of controller on the desk there, that's what they use to pilot. And it doesn't have any feedback, so it doesn't like vibrate or like give any pressure to know that like you're hitting something. So it's all about like visual feedback from the cameras. So it's tricky.
All right. Well, behind the scenes, I want all the classrooms to get ready. I want you to unmute your microphones behind the scenes, because in a minute, I'm going to bring you all in for a big goodbye and thank you. Hopefully loud enough for the whole crew to hear. So get those microphones ready behind the scenes. Get them unmuted. I want to start off with a big shout out to all the classrooms who tuned in via YouTube. Thank you so much for sending in all those great questions and, of course, playing a little Kahoot with us. I want to share the link one more time here for nautiluslive.org, where not only can you tune in live to the action that's happening, especially when the ROVs are in the water, but you can also find some great video clips from past expeditions, which are definitely worth checking out, like the sperm whale and the octopus garden, and on and on and on and on. It's always a highlight reel coming off of Nautilus. And then a huge shout out to everybody who joined us from the ship today. So Lindsay G, Ariana and Elijah out back. And then, of course, Jashida and Abrian for joining us and sharing your experiences on the ship and answering all those questions from our students today.
Thank you.
Thank you, guys.
All right, students, it's your time to shine. I'm going to bring in all the classrooms nice and loud. A big goodbye and thank you before we sign off tonight.
It's nice to meet you guys.
All right. Thanks so much, everybody. We're going to sign off for today. Enjoy the rest of the journey.